So our first topic, first question of means today's lecture is question number 19 of exercise of equilibrium. So question is, a sample of pure PCl5, it was introduced into an evacuated vessel at 473 Kelvin, and after equilibrium was reached, the concentration of PCl5, it was found to be 0.5 into 10 raised to power minus 1 mole per liter, means it is actually 0.05 mole. Okay, and if Kc is 8.3 into 10 raised to power minus 3, so what are the concentrations of PCl3 and Cl2 at equilibrium? So initially, we have reaction between PCl5 and that will give PCl3 and Cl2. So reaction is, see, PCl5, it was introduced into evacuated vessel, and this PCl5 is in equilibrium with PCl3 and Cl2, right? Now initial concentration of PCl5, it is 0.5 into 10 raised per minus 1. So it is 0.05 actually, initial concentration in mole per liter, right? And it is 0. Now at equilibrium, what happened? So you can see, if 1 mole of PCl5 decomposed, we get 1 mole of PCl3 and Cl2. This reaction we know from the chemical equilibrium as well. PCl5 has a trigonal bipyramidal geometry, and axial bonds and equatorial bonds. Axial bonds are longer than equatorial bonds, weaker than equatorial bonds because of more inter-electronic repulsion, or bond pair repulsion, we can say. So axial bonds can break easily, so it turns into PCl3 and Cl2, right? So 0.05 out of 0.05, let us take X. X is the molar concentration of PCl5 which gets decomposed. Okay, means out of concentration of PCl5 was found to be, okay, after equilibrium it is found to be 0.05. okay, sorry, that means let us take initial concentration as X, because initial concentration is not given to us, but at equilibrium it is given, it is 0.05. that means how many moles of PCl5 that decomposed? Yes, question for you. Initial moles are X, and at equilibrium now moles are 0.05. So how many moles of PCl5 are decomposed? Can you tell me? Yes, moles of PCl5. Moles of PCl5 decomposed. Yes, tell me. Is equal to? Yes, beta. Initial concentration is X. Out of X, how many moles are decomposed? That net moles at equilibrium remains 0.05. So how many moles get decomposed? So it should be, yes, see, initial concentration is X. Out of X, how many moles are decomposed? X minus 0.05. So these moles are decomposed at equilibrium. So it is now 0.05. Okay. So that means PCl5 is x minus 0.05. Cl2 is also x minus 0.05. Yes, tell me. Did you get this point? That initially we have x moles and at equilibrium how many moles left? That is 0.05. So how many moles get decomposed? That is x minus 0.05. And if 1 mole of PCl5 is decomposed, we get 1 mole of PCl3 and 1 mole of Cl2. Okay? Beta, got my point? Yes, Anika, Abhay, Sakshi. And what about others? Did you get this point? That moles of PCl5 decomposed equal to x minus 0.05. And that's why moles of PCl3 formed is equal to same, and moles of Cl2 formed, that is also the same. Okay, great. So now apply the law of chemical equilibrium. Applying law of chemical equilibrium. So Kc is equal to PCl3 Cl2 over PCl5. That is Kc is, yes, what is Kc? 8 point, what is Kc? Kc was 8.3 into 10 raised to power minus 3, right? And that is equal to x minus 0.05 into again x minus 0.05 divided by 0.05. Okay, so from here 8.3 into 10 raised power minus 3 means 0.0083 equal to x minus 0.05 raised to power 2 divided by 0.05. So that implies x minus 0.05 raised to power 2 equal to 0.083 into 0.05. So x minus 0.05 whole square is equal to, yes, 541. So 415. So value is, see, 3 decimals, 2 decimals, total 5 decimals. Out of 5 decimals, let us take this as 4.15 into 10 raised to power minus 4. Is it right? Got it? 0.0083, na? Zero point zero, so 1, 2, 3, 4, 5, 6 out of 6. So 2 decimals, we take this as 4.15 into 10 raised power minus 4. Otherwise, we can write it as 415 into 10 raised power minus 6. Okay, so it is 4.15 into 10 raised power minus 4. So now x minus 0.05 is equal to, yes, so almost, see, 2 whole square is 4, 2 square is 4. So it is value is 2 point something. Okay, so take it as 2 point, yes, if we take it as 2.1, then it is okay, it comes out to be 441. Okay, means 4.41, but it is 4.15. So it is, take it as 2.05 or 04, okay, into 10 raised per minus 2, or because it is actually not equal to 2, it is somewhat greater than 2, because if it is 2 means it should be 4, it is 4.15. so take it as 2.0 something, okay, 2.04, because it is 2.1 and 4, so it is in between, but it is close to this side. See, 4.15, okay, it is 2.10, it is 2.00, okay, and it is 4.15, so it is nearer to, means it is less than 2.05, value should be less than 2.05, so I took it as 2.04. okay. Beta 6:30 to 7:30. Okay, so it is 0.0204 x minus 0. So x is equal to 0.05 plus 0.0204. So value comes out to be 0.0704. Okay, or almost 0.07, but slightly greater than that. Okay, so what is the molar concentration of PCl5? That is 0.05. So molar concentration of PCl3 at equilibrium, that is equal to 0.07, how many, x minus 0.0705, so 0.0704 minus 0.05, so it comes out to be 0.0204, and molar concentration of Cl2 same, okay, that is 0.0204. Okay, that's it. So this is question number 19. Okay, now come to question number 20. Now question number 20. So according to question number 20, we have statement as one of the reactions that takes place in producing steel from iron ore is the reduction of iron 2 oxide by carbon monoxide to give iron metal and CO2. Reaction is given to you. Okay, so first of all write the reaction. It is FeO solid plus CO gas to give Fe solid plus CO2 gas. Okay, now see, what are the equilibrium pressures of CO and CO2 at 1050 Kelvin? If initial pressures are, see, pressure of CO is 1.4 and pressure of CO2 is 0.8. They are given to you initially. Okay, so initial pressure, see, FeO is solid, Fe is solid, so that is not counted in the expression. So initial pressure of CO is 1.4 atmosphere and CO2 is 0.8 atmosphere, right? This is the initial pressure. Now, what are the equilibrium pressures of CO and CO2 at 1050 Kelvin? Nothing is mentioned. Okay, Kp is not given to us. or it is given to us. Yes, Kp is given to us. Yes, that's what I wanted to find, because we should have Kp. Okay, so Kp is given to us. So now it becomes very easy. Say 1.4 out of 1.4 and 0.8. Okay, Kp is 0.265. That implies that first of all we should note that reaction will go in the forward direction or backward, because reactant and product both are given. If reactant and product, only reactant is given, we know reaction will go in the forward only. If only product is given, we know reaction will go backward only. But when reactant and product both are given, then we cannot decide by our own where reaction will go, or reaction will favor which direction. So what we do, we calculate Qp, is pressure quotient, and we compare this pressure quotient with equilibrium constant. So Qp for the given reaction is pressure of CO2 divided by pressure of CO. So pressure of CO2 is 0.8 atmosphere, pressure of CO is 1.4 atmosphere. So value is, okay, 8/14. Yes. So 0.80. So 14 5s are 70. Okay, then 10. Okay. So 98, 14 7s are, yes, and 20. So 0.571. That is Qp. Now Kp is 0.265 and Qp is greater than that. As Qp is greater than Kp, that means as Qp, that is 0.571, that is greater than Kp, that is 0.265, then what it means? Yes, tell me what it means. Reaction will go in which direction? Forward or backward? Yes, beta. Reaction will move fast. Reply fast. This means the reaction will move in the, keep in mind the relation between QC and KC, same as QP and KP. Beta, it will go in the backward direction. QP is greater. That means product is more than the reactant as compared to at the equilibrium. Right? Qp is greater. If Qp is less than Kp, then reaction goes in the forward direction. Now it will move in the backward direction. To attain the equilibrium, because say Qp is more, okay, so it should decrease to become equal to Kp. So to decrease, product should be decreased and reactant should be increased. So reaction moves backward. Okay. So now write the reaction once again. Okay, beta, don't worry, but you should reply. That is first and foremost thing. You should answer the question. Whether it is right or wrong, that doesn't matter, but at least apply your mind. To sharpen your skills, you should apply your mind. Okay. So initial pressure is, yes, initial pressure is 1.4 atmosphere and 0.8 atmosphere. So in the first step, we have determined that reaction will go in the backward direction. As it will go in the backward direction, that means CO2 will decrease. So 0.8, let us take minus P. So obviously, if 1 mole of CO is decreased, CO2 is decreased, so obviously 1 mole of CO will be formed. So it becomes 1.4 plus P atmosphere. Okay. So at equilibrium, Kp is equal to pressure of CO2 divided by pressure of CO. So it is 0.8 minus P divided by 1.4 plus P, and that is equal to 0.265, right? So now 0.8 minus P is equal to 0.265 into 1.4 plus P. Now solve it. Zero 0.8 minus P is equal to 0.265 into 1.4. So use the, for the time being, use the calculator. Okay. So 0.265 into 1.4. So it comes out to be, yes beta, calculate beta, 0.265 into 1.4 plus 0.265 into P. So it is, yes, 0.265 P plus P, and that is equal to 0. See, minus P will take on this side, so it become plus P, and 0.8 minus 0.265 into 1.4. What is the value? 0.265 into 1.4. 0.265 into 1.4. Can you calculate? Into 1.4. I am using calculator for the time being, but you can calculate. Okay, so 0.371. Okay, now 0.8 minus 0.371. So it is very simple, it is 0.429. So from here it become 1.265 P. So P is equal to 0.429 divided by 1.265. Okay. Again, calculation is tedious. See, so it comes out to be 0.339 atmosphere. Okay. Now pressure of CO at equilibrium is equal to, yes, 1.4 plus P that is 1.739 atmosphere. Okay, and pressure of CO2 at equilibrium equal to 0.8 minus 0.339, that is equal to 0.461 atmosphere. Okay, so this is question number 20. Any doubt? Yes, beta, very good. Am I not audible to you? Hello? Hello? Beta, something is wrong with your uh, earphones, because it is audible. Okay, so now question number 21. So 21 question is equilibrium constant Kc for the reaction N2 gas plus 3H2 gas to give 2 NH3 gas. This is the reaction, okay? At 500 Kelvin is 0.061. Now at particular time, the analysis shows that the composition of the reaction mixture is 3.0 mole per liter of N2, 2.0 mole per liter of H2, 0.50 mole per liter of NH3. So, is the reaction at equilibrium? If not, in which direction does the reaction tend to proceed? To reach the equilibrium. So what we do, we calculate QC and compare it with Kc. Okay, beta. Got it? First, what we do, we have KCC. The value of Kc is given to us. For the given reaction, value of Kc is given, okay, at 500 Kelvin. Okay, now at particular time the analysis shows the composition of the reaction mixture is, we have 3.0 mole per liter of N2, 2.0 mole per liter of H2, 0.50 mole per liter of ammonia. So now we have to show, is the reaction at equilibrium? So to determine it and to detect, what we do, we calculate Qc for the reaction and compare it with the Kc. If Qc is equal to Kc, then reaction is at equilibrium. If Qc is less than Kc, reaction goes forward. If Qc is greater than Kc, reaction moves backward. That's what we have to do. Okay, so the given reaction is, yes, given reaction is N2 gas plus 3H2 gas to give 2NH3 gas. This is the reaction. So Qc from the given reaction is, you can write the concentration of N2, H2, ammonia before that if you would like to do it, but otherwise write directly. Concentration of ammonia raised to power 2, concentration of N2 raised to power 1, concentration of H2 raised to power 3, right? Now, whatever the concentration of ammonia, it is 0.5. So that is whole square divided by concentration of N2, it is 3.0 raised to power 1, and H2 2.0 raised to power 3. So that is 0.25 divided by 3 into 8, that is 0.25 over 24, very close to 25. That means Qc is equal to almost 0.01. Okay, but it is 25. So say it become 100, means 0.04, 0.0104. That is the Qc. Now compare it with Kc. Value of Kc is 0.061. 0.061. That means value of Qc is, as the value of case Qc, that is 0.0104, is less than Kc, that is 0.061. So the reaction is not in the state of equilibrium, right? The reaction is not in the state of okay. So where it will proceed? Tell me now. It will proceed to the forward direction or backward? Yes. It will proceed to, yes, it is for you, till Qc becomes equal to Kc. It will move in, yes, it will proceed in which direction, beta? Very good. Now it's good. It will proceed in the good away, forward direction. Okay, till Qc becomes equal to Kc, because Qc is less than Kc. In the previous question, Qc is greater than Kc. Okay, because if Qc is equal to Kc, then reaction is at equilibrium. And if QC is less than KC, means it will proceed in the forward direction, and if QC is greater than KC, then it will proceed in the backward direction till QC becomes equal to KC. Right? Okay. So let's stop here today. Okay. Tomorrow is Sunday. So, have you any plan in the morning? If you are free, I can take your class. Because see, in this chapter, equilibrium, we have almost 70 questions of exercise. And I don't want to left any question. So we will use even Saturday, Sundays. How many questions are there? "73 questions are there, beta." So if you allow, I can take your class tomorrow as well. So tomorrow at 8 o'clock. Tomorrow at 8 o'clock. Is it okay? Are you people free at 8 o'clock tomorrow? Or we'll keep it on Monday? Okay. Okay. Abhay said okay. What about others? I don't know. So Abhay, you should write in the group. Okay. Just write in the group. Morning, beta. 8 a.m. Okay, inform all. We will keep the class at 8 a.m. Chalo, bye bye beta. Take care.